So I started building this station 14 years ago, and I'm glad I did it at 60 and not 74. So there's my station out on the plains of Colorado. Nothing but monoband beams, and there's 9 of them for HF, and then they'll clear up through 70 centimeters. That's where I just got snowed in. So I was lucky to get out yesterday and get back to Denver. Not that I couldn't have done the presentation from there, but that's what happens in Colorado at times. There's operating position number 1. And because I compare equipment in contests, I often want to have a reference radio, and that's changed over time. As you can see, we've got a bunch of rotator controllers there for the 6 towers. And so there's an ICOM and an alpha, and you can switch. And there's the little 9700 up there on top. There's operating position number 2. Normally to have a Kenwood there, but the Kenwood's broken at the moment. So we have another 7610 there and another alpha. Then the last position there is does double duty, 630 meters with the little 7300, and the 7610 in this picture what got moved to the other location, and then the ACOM up there. So that's what I do when contesting. I'll typically set up 10, 15, and 20, and I just change chairs to change bands. That's the daytime setup, and then the evening it'd be 40, 80, and 160. So that's how I play around in my place. So we're going to be talking about, I've talked about receivers now for decades, but really the transmitters have become more of an issue as the receivers have improved dramatically. So sometimes the problem is the other guy's signal and his bandwidth. So we'll talk about that. And we don't want to just focus on a few transceivers. There's like 150 or something in that number on my website. I started testing radios back in '76. And the choices today are just astounding. So you're not stuck with a brand or a price range. It's just amazing. I do get emails and phone calls, and they'll say, well, why isn't your website ranking by sensitivity? Because we want to hear that weak DX. And it's really not an issue. If we go back to an R390A, and I'm sure a lot of you know what that was and maybe even own one at some point, well, the sensitivity in microvolts was 0.2. And a Drake R4C that I sold kits for 45 years, 0.2. And a K3S with preamp number 1 on 0.2. So you can see sensitivity hasn't been a problem for a long time. Heck, a 75A4 was plenty sensitive. It had some overload issues, but sensitivity was not an issue. But today in an urban environment, really, RFI from our urban environment is really the big problem. And so I'm lucky to be out there in the middle of nowhere. So just so you'll know, by definition, well, what is sensitivity? That's normally a sideband measurement, 10 dB signal plus noise to noise ratio in a 2400 or whatever the standard bandwidth is. I listed in microvolts for historic reasons, because we've got data and advertisements, back from the 50s and 60s and 70s, and until we had this new term, noise floor, which is a 3 dB signal plus noise to noise ratio, usually measured in a 500 hertz CW bandwidth. It's kind of fun to compare things to the past. So those 3 receivers or transceivers I mentioned earlier, well, if we do it by noise floor, they're virtually identical, obviously within a dB. So that works out that way. But local noise has really become a major problem. I would guess, and this is just a seat of the pants guess, but I've lived here at this house for 5 decades. And I would say the noise level has gone up about 3 dB per decade, and it may be increasing faster each decade. We've got lots of noise sources. I don't think line noise is as well controlled. We've got all sorts of wall warts to charge up our cell phone or whatever we've got for a electronic gadget. And they used to just be a transformer and a couple diodes, but now they're a switching power supply. And guess what? That can make noise. Of course, all the computers have switching power supplies, and our household appliances, dishwashers, washing machines, dryers, they've got microprocessors in them, and sometimes they make racket. Our lighting may make racket. DSL and VDSL have a radiation way beyond your house. And of course, in Colorado, and I guess probably in California too, we've got pot grow lights that sometimes can wipe out, 10 blocks at a time. So there's lots of sources of noise that we didn't have to deal with back in the 60s. So I'm going to talk about, from a receiver standpoint, dynamic range, the search for that magic 100 dB radio. Of course, there's nothing magic about 100 dB. It's just a nice round number, something we wish we had 20 or 30 years ago, and it's not uncommon today. So 160 through 10 meters, we can buy an amazing radio today. So what is dynamic range? And that's really the ability to copy and work weak signals in the presence of lots of strong signals without the receiver creating its own QRM. And if we go back to the 20 or 25 years when all we had was what we call up conversion radios, once we got away from a Drake or a Collins with a PTO and band crystals, we had general coverage and digital readout, but they really weren't high performance, particularly for CW or RTTY. So for instance, the last of those from ICOM was the Pro 3. And if we did this 20 kc test that is the way it all started out at the ARRL, it really didn't test much of anything except the front end. And I'll explain that. So now if we look at what's available in the market, except for the very expensive 7851, the up conversion radio is kind of gone because it couldn't compete with the what we say down conversion, and that's really a misnomer. I mean, if you're on 160 and the IF is 9 megahertz, it's not down, but it's not a 40 megahertz or a 70 megahertz IF. And then examples of new transceivers in just the last couple of years, the amazing upgrade from Kenwood with the 890S, the two new Yaesus, the 101D or the MP, and then the FTDX10 that's just been out for a modest number of months. And then there's all the direct sampling radios that just came out recently. Of course, we've had the 7300 and the 7610 for a while, but the 9700 for VHF, UHF, and the little 705. I'd like some feedback at some point during Q&A. How many of the SOTA guys and the Parks on the Air, I just wonder how many people are using little 705. And we know now of at least 3 K4s that ship to regular customers and not beta testers or who knows what type of a prototype. So at least on the groups.io reflector, we know that 3 people actually have one. So this is an improvement. So what numbers are most important in a multi-signal environment? If we're the only station on the band, it hardly matters. But if we're in a CW pile-up contest de-expedition, hopefully we'll have some more of those soon because that's been sparse, obviously, for obvious reasons. So we need the dynamic range there, particularly CW and RTTY, and I'll explain why that is versus sideband. Not that it's not important, but it's not as important it is with the narrow bandwidths. Well, even though I said the noise floor isn't a problem as far as buying a radio that's adequately sensitive, we do need to calculate what the dynamic range number is. So that's part of the equation. Reciprocal mixing dynamic range. Now that's a relatively new term that the League, ARRL, coined in 2012, kind of because I was making a stink about something else, but it's the phase noise of their transceiver. Of course, we didn't really have to worry about phase noise back in the Collins and Drake days or Swan because they were pretty clean. But then we got synthesized radios, general coverage and all that good stuff. But the synthesizers, they were terrible for a long, long time. And it's really only in the last few years that we've had amazing synthesizers that don't limit the performance of the receiver and even the transmitter. Because if you've got a lousy synthesizer, it's going to affect on transmit too. So I'm going to touch on transmit broadband composite noise. Composite noise means total noise, phase noise, AM noise, and that can be quite different from one rig to the next. Well, if we work sideband, we know what splatter's like, and the guy that's up the band 3 kcs, let alone 5 or 10, and we're hearing him in our pass band with our great digital selectivity, well, that's a limit. And then if we're in a CW contest, maybe you can't work somebody because of the guy that's 1 kilohertz away has terrible key clicks. So this is things we have to deal with today. So dynamic range and noise floor were defined in QST and Ham Radio Magazine. Oh, don't I wish that Ham Radio Magazine was still around, in 1975. So to test it in the lab, you feed in 2 very well isolated signals, and you start looking for the third order intermod product. Just like if you look in QST for an amplifier or a transceiver and it'll look at the transmit intermod, third order usually is the worst. So when we're testing a receiver, we're doing the same thing. We're looking for distortion generated in the receiver portion. So we have to know the noise floor versus the dynamic range. So that level that we're feeding in, let's just give an example here for the Magic 100 dB radio. Let's say the noise floor is minus 128 dBm, and that's a reasonable number. Preamp off usually, particularly if you're in a potential overload situation with lots of strong signals. And let's say the 2 test signals that we fed in to look for that third order product, which means that 3 dB signal plus noise to noise ratio, that distortion product is going to equal the noise floor when that distortion goes up 3 dB on our analog RMS meter. So those 2 numbers are 100 dB different. It could be 79, it could be any number, but in this case, there's our example of our Magic 100 dB radio. So as I said, synthesizers were pretty awful for a long time, and not so with several newer products today. But you say, well, what difference does it make if the local oscillator is noisy? I'm not listening to my local oscillator, and that's true. So let's look at this little guy on the left. That's bullet nose weak signal, that's DXCC 100 or zone 40 or whatever it happens to be. And fairly nearby, there's a really strong signal. And it could be a perfect signal. Of course, a perfect signal doesn't exist. But the noise sidebands on the local oscillator mix with the strong signal that's nearby and puts a modulation envelope on the strong signal that's out of your passband and can cover up the weak signal. Now, this cute little graphic that I found on the web, that implies that we expect the noise spectra of our local oscillator to fall off fairly quickly, and we would hope it would, but it doesn't always. There are some radios that they're just as bad at 100 kilohertz as at 10, or maybe 300 kilohertz as at 10 kilohertz or 5 kilohertz. So sometimes we could be like on field day and have a radio that had very poor reciprocal mixing dynamic range, and we're on CW, and we've got another station on the same band, on sideband, and they could be bothering each other. And likewise on transmitted noise. So you just never know. So when we look at product reviews, we have to pay more attention than is obvious. We have to look at the devil's in the details. And you should always read Bob Allison's sidebars when they show up in QST. He's the lab technician that makes all these great measurements. And so in April of 2012 and May of 2016, he wrote 2 separate sidebars explaining what this phase noise reciprocal mixing dynamic range is all about. But as I just showed you, it has to do with whether our local oscillator is clean enough so that it doesn't degrade our reception capabilities. And actually, for most of those years of synthesized radios, the synthesized noise was actually dominant a lot of the time. And if you go to my website, often, since it is sorted by close-in dynamic range, but if it has a footnote that happens to be F, the footnote F, it'll say that's phase noise limited. So that was really often the case. Then for some reason, the league decided they didn't really like saying that the radios were phase noise limited. So they wanted to measure the distortion product, even if it was buried in phase noise. And I don't have a problem with that from a technical standpoint, because if you were the radio designer and you needed to know, well, what's the limit on my radio? Is it my synthesizer or is it my mixer, for instance? Well, you'd like to know where, even if the distortion product was buried in phase noise, you'd like to know that. But for the average user, or actually any user, all we want to know is what's the limit. So if we look at the FTDX 3000 product review in QST, it said the dynamic range was 100 dB. And I'd already published on my website before this actually came out in QST, I'd said it was 82 dB worst case, and that was phase noise. Well, actually, if you read the review carefully, it wasn't obvious then. Well, they also said the reciprocal mixing dynamic range was 82 dB, the exact number that I'd published on my website. So if we've got a review for how a radio is handling strong signals, well, if we've got one number that's 82 and one that's 100, for example, we'll just ignore the big number because that's not the limit. Well, that was a while ago, 2013. Just had a review of the Zygu G90, and that's a, well, sort of QRP. It goes up to 20 watts. And matter of fact, I just ran it through the lab recently, and it'll show up on my website probably this weekend. Well, it had the same thing where they measured the third order dispersion product with maybe a 1 hertz filter or a 10 hertz filter with a spectrum analyzer and came up with 91 dB. But the reciprocal mixing limitation, which is the real number in this case, was 84. So you just have to read the reviews carefully so you know what's the radio potentially going to perform in a worst case scenario. The other interesting thing, I say, you read Bob Allison's sidebars. He was talking about the G90, and he said it had mediocre keying sidebands. Well, what's that mean? Key clicks. He said the IMD splatter was not up to par, and the transmit, in this case, noise, they don't measure composite noise, but anyway, that's another subject. He said, don't use an amplifier with it because you're going to cause a lot of interference on the band. So those are the things we really don't want to do. We have to share our bands, as we all know. And if someone's wide due to key clicks or splatter or transmit noise, that's not really fair to everybody else. And so here's just another example of where the numbers can really be misleading. The blocking definition for an analog radio anyway would be when we start gain compression probably in the mixer, maybe an IF stage. And so they listed blocking as 121 dB at 5 kilohertz. But they also listed the reciprocal mixing dynamic range, the phase noise limitation, at 5 kilohertz of 84 dB, 37 dB lower than the blocking value. So again, just throw out that 121 number. So as I mentioned, for a long time, the reciprocal mixing phase noise performance actually was more dominant, at least close in, than the dynamic range measurement. But this is changed recently of the, we'll call legacy, and that's not a detrimental term, but of the older design super hets, we now have the K3S, which has a wonderfully upgraded synthesizer. I don't know if you can buy an upgrade for your K3 right now, but maybe once Elecraft gets the K4 shipping and volume, they'll make some more synthesizer boards. Of course, the 7851 at $12,000, it has a clean synthesizer, but the FTDX 101D or the MP, well, those were two models were the first rigs from Yaesu, I think, ever that really had good synthesizers. And then the FTDX 10, a little bit lower than the 101D, but not much, at significantly lower price. And then the TS890S, a big improvement close in over the 990S. Now the 990S at 20 kilohertz or more was fine, but close in, a pile up on CW is not 20 kilohertz away or something. So the 890S, big improvement. Now the direct sampling radios, all you have to do is put a good clock oscillator in a direct sampling radio, and you don't have a phase noise problem. So that makes it actually easier to do than look at all the decades it took to come up with a good synthesizer. So the ICOM, the Flex, the Apache, those are our main direct sampling radios, and they don't have phase noise troubles. So we're a third the way through. So if anyone has a question, and also my question is, there's Soda guys or Parks on the Air, is that little 705, or are people interested in that? So host, see if we have any questions with your group.
Yeah, Bob, this is Bill N6GHZ. Have you looked at any of the low-cost SDR receivers, just receiver only, such as the SDR Play and some of that low-cost SDRs? And do you have any feeling how they compare with the newer direct sampling? And in what area do they lack?
Well, I don't own them, and some of my friends do have the SDR Play and some other ones. Uh, I consider them more of an adjunct. For instance, if you've got a TS590SG and you don't have a band scope, those are the perfect way to get a band scope at a very low cost. I mean, they're not going to have the performance you would expect out of a transceiver, and even I've got that right now. There's 9 QRP transceivers on my list, and there will be 10, and some of them are pretty darn good. So I just consider that an accessory more than we're not going to work a contest or DX. I don't think. I guess you could use a Viking Valiant and a little SDR Play, but I don't see the point. So I don't. I mean, there's so much time spent in testing these radios that I just haven't put the time effort into trying to test all these little dongles. But they're for the money, they're a great little way to experiment or to add a band scope to your radio.
Thank you, Bob.
Okay, we'll continue on. So today there's two basic types of transceivers: the super het that was been around forever, and the direct sampling, and then the hybrid super het. Well, the hybrid super het is really a super het like a K3 with a direct sampling band scope. I mean, when the first radio that I owned, and it certainly wasn't new, that had a band scope, and maybe the first one that was on the market was the ICOM 781, and then clear up through the Pro 3, but the resolution isn't anywhere near what we can get now with a hybrid or a direct sampling radio, whether it's a little 7300 for $1,000 or the 101D for 3,500 or whatever the cost is. So we have a lot of resolution now with the hybrids that make them just as good as the direct sampling. At the same time, the super het has an advantage in some RF environments. I don't know if your club does field day, if you have multiple transmitters on the same band, but a super het has a roofing filter. Even if it's just a wide roofing filter, it's going to knock out most of the stations on the band. So from the standpoint of blocking, a super het might have an advantage as much as 25 dB over a direct sampling radio. But most of the time, that's not an issue because we don't have to deal with enormously strong signals. So like the ADC overload for most of the direct sampling radios, which are going to be the ICOM, the Flex, and the Apache, around S9 plus 65 dB. Now, I don't see signal levels like that at my QTH, but if you've got a ham a mile away, and certainly if it's field day, that's just acid test. I've had a few stations, hams call me up or send an email saying a ham moved in 2 blocks away. I think I'm going to have to buy a new radio. Well, if you've got a ham 2 blocks away and you hope he doesn't have a radio that has terrible transmit noise, well, you're off with the radio with the roofing filter. To give you an idea of why, well, I mean, when all the synthesized radios came along and didn't have pre-selectors anymore, like on a Drake or a Collins, they pretty much used half octave LC filters. Now on 20 meters, here's an example of the current ICOM products. Well, the front end filter, LC, covers about 11 megahertz to 15 megahertz, or maybe 16 megahertz. And that's a lot of bandwidth because there's commercial stations in there too. So the analog to digital converter chip is going to have to deal with that whole swath of signals. So in that case, you can see why the roofing filter, maybe it's 2.7 kilohertz wide, maybe it's 500 hertz wide. And even if it was 10 kilohertz wide with the older radios, it's still a whole lot less than 11 to 15 megahertz. But if you're not seeing signals, way over 60 over 9, it's probably not an issue. But that's If you're in Germany with the on 40 meters at night, that's a tough one. So what features are desirable today? Well, the first two here are CW oriented, QSK, or at least click-free semi-break-in. I generally run semi-break-in, but I certainly want to hear between words. I want to know if I've called a station and he came back to somebody else. I don't want to step on him again, so I want to hear. I want an audio peak filter. I don't necessarily use it to make my selectivity narrower, because with DSP you can pick any bandwidth you want pretty much, but it takes the edge off noise. So I tend to run it about the same bandwidth as my DSP filter, and that helps out. And I'll talk about noise a lot more in a bit. Well, I won't buy a radio today that doesn't have a built-in scope and waterfall. I think when I saw the 781 come out like 30 years ago, I thought, people called them fish finders. Well, guess what? They find signals. And the other thing is, if you're seeing a splattery signal on the air on your band scope, that's real. We want an efficient user interface, particularly for contesting, but even for DXing, particularly DXpedition. We want to see where the other guys are calling him. So we want to be able to adjust things, maybe listen on the second receiver or listen on the transmit side frequency or whatever. We certainly want our logging program to be rock solid. Personally, with a computer controlled radio, I like a tuning knob, but some people happy with their mouse. So that's just whatever you like. Many models today are going to perform well, and I'll show you a list in a little bit. But whatever we have, we can optimize it. And if it's a station nearby that's wide, well, we can't do much about that, but we can at least run our receiver in a reasonable way. So what's available from all 6 major OEMs, at least up through 6 meters. 6 meters may be a little bit worse, but not enough worth talking about. Well, from every OEM, we can have a dynamic range that's at least 95 dB. If we go back 25 years ago, that was unheard of. And even 15 years ago was kind of unheard of. And the synthesizers now at least from the top of the line for each of the brands, is better than the 95 dB. And why we like that is we don't want a single station with a bad reciprocal mixing performance of a radio can cause interference, where dynamic range means at least 2 stations are causing an intermodulation product. So we really want that R to be a bigger number than the dynamic range number. So look at what we can look at today with wonderful performance. The ICOM line, the Flex 6000, the whole series, the Apache Anon, the K3S in particular, noticeably better than the K3, the Kenwood 890S, and then the 3 new models from Yaesu. So it's just amazing what we've got now. So how are we going to choose a new rig now? We've got so many choices that we get good lab numbers from a lot of different radios, and you'll see a list in a moment. So now we've got to be sure we don't just buy a radio for one number any more than you bought a sports car that could go 150 miles an hour but couldn't go around a corner. I mean, one number is not the whole world. So we look at the features and the ergonomics, which make it easy to use or clumsy to use. Firmware enhancements. I mean, once a radio ships with all this software. I mean, people talk about software-defined radios. Every radio today has got software in it, and it probably isn't feature-rich when it first comes out. So we want enhancements and bug fixes. I mean, there's always some sort of a bug, and they can fix that. Factory service has become more and more important. I mean, you look at the size of surface mount components, and they're even over a 5-year or 6 or 7 year period, they've become microscopic. And that may affect the long-term cost of ownership. Maybe you have to buy a whole new board. I know there are some cases of a board might be $800 in one case of an earlier ICOM. So, and then what's your operating style like versus the rig's ergonomics? You know, a rig that works for me may not work for you, just depending on how we actually like to operate on the air. So here's this list I was talking about from my website. I want to clarify that this is not the 21 from the top to the bottom, 21 radios down. There are duplicates in there. And you say, why is that? Well, the K3 came out in 2008, so it's there. And the K3S came out later. And then at one point, I was comparing a K3S to a Flex 6700 on 10 meters and setting the noise floor as identical and then comparing the dynamic range. And then these direct sampling radios, they're not as consistent from sample to sample as the superheads. It isn't that the radio itself, big picture, is inconsistent, but the ADC chip, that analog to digital chip, is not like peas in a pod. There's variations of several dB. And so I've got second samples of a lot of the direct sampling radios. So, it's not like night and day, but it varies. So of these 21 radios that start clear up at the 101D at 110 dB, which is like amazing. Well, the little ICOM 705, 88 dB, that's pretty amazing. It's the size of a brick, weighs 2.5 pounds. And you can take it up on a summit or on a park bench. So we can just have every size and price range of radio we want to look at that fits our needs. So from $1,000 to $12,000. And of course, what did the 7300 do to the used market? It crashed it. So you can buy an older radio today at a bargain price, because why would you buy a used radio if it was going to be the same price as a new one that works really well? Of these 21 radios, transceivers that I've used, of the 21 in the list, I've used 15 of them in at least one contest, if not more. And for instance, N2IC is a big contester. If you pay attention to the results, he just has a pair of TS590s. And those are certainly modest price radios. So it comes down to lots of things besides just the radio: location, antennas, operator skill. And the radio is important, but antennas are pretty up there on the list. So I'll make a few comments on the newer things that just came out, the 705, and I am anxious to hear if any of you guys in the club are using it. So it covers 160 through 70 centimeters. The lab numbers are virtually the same as the 7300 with this IP plus turned off. Now, what is IP plus? That's a linearization feature in the chip of the 7300 and the 7610. And the Apache, for instance. Flex does it differently, but it does the same thing. But in reality, at least on the lower bands with the sunspot cycle the way it is now, I've never yet had anyone say when they turn this linearization feature on and off on the ICOM or on the Apache that they can tell a difference. But probably that reason is because the low-level distortion products in a direct sampling transceiver are probably below band noise on 80 meters, 40 meters, 160. But this will be interesting once we go to the sunspot peak in a few years here on 10 meters with, CQ Worldwide or AWLDX. There'll be hundreds of thousands of stations that are going to be strong. And maybe we'll notice this linearization being more important when we can have such a much lower noise level on 10 and 15 meters, for instance. So I considered the 705 pretty much on HF. I didn't use the satellite features or anything like that. It worked just like the 7300. The ergonomics were good, and the scope just worked like I was used to. For the user interface, if you can run a 7300 or a 7610 or 9700, guess what? You can run a 705. It's just a piece in a pod there. The FTDX10, $1,700. The numbers are a little bit less than the 101, as we'd expect, but not a lot. I had some issues with the ergonomics, and if anybody wants to ask questions about that, Q&A, we can talk about that. The funny thing is with the 101 and the 10 is the waterfall plays along, and that gives you a history what's happened over the last, say, 15, 30 seconds. But you tap the key once, or push to talk, it all goes away. Even the 2D or the 3D, it all goes away. And I've complained to Yaesu about that. I mean, if I'm in a contest and I'm watching the waterfall and I'm using N1MM, which that's what I happen to use for logging, and I hit the key that hit the function key that sends my call out. Well, that takes less than 2 seconds. But once I sent my call, all that waterfall information goes away. So that's just crazy. And I don't understand that. No other rig that has a waterfall does that. So here's the contest that I ran with the 705. Now, I wasn't running QRP. I was really evaluating the receiver and all these features on HF. So I did run sweepstakes for just 100 Qs for fun. I bought a HT headset that would plug in there. The Vox didn't work, unfortunately, but push to talk did. So I ran just 100 contacts on sweepstakes. I did run the entire ARRL 160 meter CW contest with the 705, driving linear. Almost 400 contacts, search and pounce only. My CW skills aren't really good enough to run, but I had a lot of fun doing S&P. I worked a couple JAs, obviously sensitivity, no problem. 80 sections, 16 hours on the air. So it was a great little experience. I also operated the ARRL 10 meters, CW and sideband. I didn't run the whole thing, again, because CW was fine, but I didn't have a Vox. But it worked just great. So, 160 is the opposite spectrum of 10 meters, sensitivity, no issue. So that was fun. The 101, the FTDX10, I ran that in the CQ Worldwide 160 CW, the entire contest. I was limited. I couldn't operate Sunday, so I only had over 200 Qs. 3 JAs that time on 160 and 45 sections. So I was on the air for a little over 7 hours. The selectivity was great. The audio peak filter was great. But they had the ergonomics issues with the band scope that I don't understand why it's done that way. So maybe there'll be some firmware updates to fix some of those. Some of the things that I considered bugs when I talked to Yaesu about it, they said, well, that's just the way we designed it. But some of them, they said, well, you're right, that doesn't make sense. So again, we're looking for a firmware update. The radio's only been out a short time. So here's the elephant in the room. Where's the K4 going to fit in this table? Well, we don't know, but we do know the architecture, and we've gotten more and more information from Eric and Wayne over the last several months. So a K4 will be like half of a 7610, one ADC chip and one set of bandpass filters. A K4D will be architecturally just like a 7610, 2 complete receivers with separate chips and separate LC filtering. So you could have one on 160 and one on 6 meters. Now with the K4, you could certainly have 2 receivers, 2 slices of the way Flex calls it. But if you were going to go on 2 different bands, you'd have to go wideband on the bandpass filters. But if you're just going to do working split on 40 meters, no problem. Like for a sideband contest where some of the guys are down below the end of the CW portion of the band call on out of state, out of the country. And the K4 HD, well, that'll be interesting. No idea when that'll ship. It's now going to have up to 3 roofing filters per receiver. So it could have 6, but a roofing filter is probably $100, $150. That adds to the cost. So that's going to be an option, I understand now. So maybe it would have to ship with 1, but you can put 2 or 3 in it, depending on your needs. So that architecture would be like the FTDX 101D. It would be a super het with direct sampling capability, so you can run it either just as a K4D or as a super het. Pricing is interesting right now. You can get a lot of radio for $3,000 plus or minus, and the K4 is going to be kind of pricey in comparison, but they're going to be talking about features. And so like I said, features may come down to what radio you're going to buy, because they're going to work, all of them are going to have the basics. I have no idea what the K4 HD will cost, but we'll find that out one of these days. The pricing here all included every radio. If the tuner was an option, I included it because most radios come with a tuner built in. So to make it a level playing field, the couple of radios that didn't have a tuner, I added that as an option. So, and this PDF will be available if anybody wants to look at those numbers in more detail. Pay attention to net gain. So I'm going to talk about how do we run our radio the best way possible, whatever radio it is. And I'm going to show you slides from 10 meters to 160 in contests. And how do we decide when to use the preamp? when should we use an attenuator? I don't know that many people use an attenuator as often as they possibly should. I mean, 40 meters at night, attenuator makes sense. Preamp makes no sense unless you have some RX antenna. But if we're on 15 meters in a quiet location, well, preamp makes total sense. So we'll look at some options here. This dynamic range that in that list there went from 110 clear down to 88. Consider that a window of performance, and we can move the window up if we're in a potential overload situation or we are on the lower bands where the band noise is high. We can use attenuation and just move that performance wherever appropriate. But if we're on the upper bands and we do have a quiet location, well, we're going to probably want the preamp. And in effect, it moves the performance window down. We're trading off potential overload for more sensitivity, and that makes sense. And really, the preamp in any modern radio is not going to degrade the dynamic range of the radio, maybe 1 dB or something. It just, so it's this gain adjustment, net gain is going to just move this virtually constant dynamic range up and down. So here's the ARRL 10-meter contest in 2018. Now, of course, we were at the bottom of the sunspot cycle, but there were still plenty of stations to work. You can see here, there's over 20 stations in a 10 kilohertz bandwidth. This happened to be a TS890S. Well, what do you see over on the right? Upper right, preamp 1 is on. So I'm out there in the country, so that makes sense. I don't have noise to be worrying about. And down at the right, lower right, it says APF on. So I always run the audio peak filter on CW. It just takes the edge off whatever band noise is there. Well, here's the opposite extreme. This would have been the weekend before, same year, 2018, and over 30 stations in a 10 kilohertz bandwidth. You look at how much more QRM there is. Well, there's lots of things to look at in this one, more than I even thought when I took the screenshot. Well, in the sort of upper middle, audio peak filters on, you can see the red arrow. Over on the left, well, the preamp's off, and I've got the 12 dB attenuator on. Well, you say, why did I want to do that? Well, band noise is 30 dB higher at night on 160 than it is on 10 meters during the daytime. So our radios are built to have enough sensitivity or noise floor to work on 10 meters and now 6 meters, of course. So we've got sensitivity to burn by like 30 dB. So we can turn on the attenuator and do two things. Reduce the potential overload from, let's say, local stations on 160. You might have a 60 or 70 over 9 signal on 160 from a guy 5 miles away or something. But also, there's no reason that we want our AGC be running on band noise. That's tiring. I mean, if you tune between stations and the band noise is as loud as every station you're working, you don't want that. So if you punch in attenuation, let's say you punched in the 6 dB attenuator, nothing changed. It probably doesn't on 160 or 80. You don't hear any difference in the noise coming out, in between stations with your headphones, your speakers. So you punch in 12. Oh, maybe the noise drops a bit. Maybe you put in 18 dB. So you really want that AGC threshold to be above band noise. Now, every once in a while, you'll be working a really weak station that you'll have to turn the volume control up. But if that's 3% of the time, in the trade-off of not having band noise as loud as every signal you're working when you're tuning into the next weak guy, that really reduces your fatigue factor for a long contest. Now, what else did I pick up here by mistake, by chance? Well, look at the signal on the left that says key clicks 5X. Look how wide that guy is. You can see him on the band scope. He's got all those wide shoulders, and certainly on the waterfall, it looks terrible. Then you go over to the right where it says clean. Now that station admittedly is 3 dB weaker, but look how narrow that guy is. The band scope shows nice and narrow. The waterfall is nice and narrow. So we don't want to be that guy on the left. We're being a bad neighbor. And look at a little more detail on the left of the guy with the key clicks. There's a little tiny signal trying to peek through his key clicks. You can see it on the band scope and you can see it on the waterfall. So I would be struggling to work that guy if the guy's calling, CQ, CQ, CQ on 30 words a minute, and I'm trying to work that guy that's being buried by his key clicks. So we really don't want to do that. Unfortunately, we can, by accident, let's say, be that guy on the left, and we'll explain that. Now in sideband, we sort of have a similar thing in that, well, how wide is our signal? And we don't have too many choices today, unfortunately. Apache has something called pure signal, which is pre-distortion. It's kind of like inverse distortion. It's used in the cell phone business. It's used on commercial television transmitters to clean up the amplifiers. Well, there's the guy on the right, says pure signal. Now I'm talking to him. That's Tyler, and he's a hi-fi SSB guy. So he's got his bandwidth set 4.6 kilohertz. I wouldn't do that, but the point is, look, his signal is absolutely straight up and down. There's no splatter products that you can see, but we look down to the left, 14 kilohertz down the band, and you can see there's sort of a typical signal that's strong. That's his splatter products are about 3 times as wide as his main signal. Flex for years has said they're going to offer pre-distortion. Elecraft says the K4 will have pre-distortion sometime. I mean, they obviously have to get product out the door and get it feature rich, but I sure hope so, because if we could all look like the guy on the right, admittedly squeezed down to 2.7 kilohertz or something, wouldn't we all enjoy the bands more than having to deal with the splatter there? And I'm in that boat. If you look at the bottom of this waterfall, that's me talking, and I'm wide. Now, the signal was 30/9 where this picture was taken, but then a guy with an Apache started talking next, and he was about 35/9, but look, almost no splatter there. So I wish that we could all do that. I wish that half the OEMs, if not everyone, offered pre-distortion. So quickly before we finish up, how do you run your radio the best way? Well, we now know that on the lower bands, particularly at night, you probably should be considering running some attenuation to adjust where the AGC threshold, and you can use attenuation with an RF gain or just with the attenuator options. But how do we know when to turn on the preamp? I mean, some people say if in doubt, turn on the preamp, but that's not really a good plan. So what we want to talk about is antenna noise gain. So here's 2 examples on 10 meters and 6 meters, a couple of 5-element Yagis on their own towers. We want to be able to go to our dummy load for a test. Now you can use an open circuit, but get your dummy load hooked up with an antenna switch or the spare port on your radio or however you can do that. And you want to go back and forth between the dummy load, which you'd only be hearing receiver noise, and hooked up to your antenna, tuned to a dead spot, of course. Well, in this case, this was a Pro 3. And with the preamp off on 10 meters, when I switched between the dummy load and my 5-element Yagi, band noise went up 3 dB. Well, what does that mean? That means the receiver is creating half the noise and the band noise is the other half. Well, that's not optimum. But if I turned on preamp 1, well, it's almost 10 dB difference. In that case, the receiver is creating 5% of the noise, almost none. 6 meters is even more dramatic with no preamp. I've never had a transceiver on 6 meters at my QTH where I could hardly even hear the antenna connect versus the dummy load with no preamp. But in that case, preamp 1, I only got a 4.5 dB improvement. I had to go to preamp 2, again, almost 10 dB, in which case the receiver noise is insignificant. And if you do work a lot of the upper bands, consider some surplus hardline instead of coax. So there's the second break. Any questions or comments about anything?
Rob,
Yeah.
I worked in the defense industry for quite a while for a company that was Ford Aerospace at the time. And we made transmitters for satellites, and we were using pre-distortion to get rid of downlink products in the 80s.
Very good. Well, the commercial guys have one advantage. They're probably on one frequency or a set of frequencies and one power level. And now we've got to deal with the our rig on all the different bands, 160 through 6, and we definitely would like to have our external amplifier in the pre-distortion loop. So it's taken years then, well, what, 40 years to get pre-distortion from the military world to our world.
Hey, Rob, this is Bob, W1RH. We have used pre-distortion for years in my career, which was broadcasting, especially UHF, using the old Klystron transmitters. But my question was, have you heard anything from Flex regarding actually making that happen?
The last time I talked to Gerald, and it's been a while, and I watched their groups.io reflector, and it says it's on their list, but it's way down the list. And I don't really understand why, because Gerald said that, I think clear back to the 5000, that they could do pre-distortion, and certainly by the time the 6000 series came out. But they've been focusing on other things, contesting more than in the past, and remote operation. But I think it's really critical. And the fact that Eric and Wayne say that the K4 will have it now, I don't know when, but I would love to have a signal straight up and down.
Hey, Rob, I have a question. Oh, go ahead. I'm sorry, Bob.
No, Rob, I had a question for you.
Rob, on the
I'll try it again. Rob, I had a question for you. You mentioned that the display on the new Yaesu FTDX 101D would go away when you transmit. Is that the same for the IF out? I typically run a like a little SDR to a monitor for a pan display on my 3000, and also on the 5000 do the same thing. Is that IF out still active during transmit?
Well, it isn't the issue of whether it's active during transmit. It's like, what happens to the data there when you quit transmitting? You just sent your call, it took 2 seconds, and all that history data went away. So when I talked to Yaesu, and actually it's the Yaesu rep in the UK, we've been talking on Skype, talking on Zoom and on email, and he said that they could fix that on the 101 and the 10 on the 2D waterfall, but they couldn't fix it on the 3D. Now, I don't understand that at all. So as far as an IF output, I have no idea. I don't know that. But nobody else's waterfall loses the history. I mean, you can go one dit, and it's gone. And I don't get it.
Thank you, sir.
Rob, I have a question on the Yaesu FTDX 5000 MP. It has a class A button. It only goes 75 watts. Does that sort of like a pre-distortion thing on transmit?
No.
Well, it's negative feedback and all that in class A, lower distortion. So I do have some slides that I don't think I have in this presentation where showing W6XX, Pete, unfortunately he's SK, but he ran a Mark V in class A, and then he drove an 8877, and his signal was outstandingly clean. So it's unfortunate that Yaesu was the only company that offered class A, and they don't do it anymore. But the class A Mark V and probably the 5000D, which I did borrow and rent for 3 months from a W1STT, that was very clean as long as you didn't hit the ALC at all, because the ALC is screwed up and has way too fast a time constant, and you kept your processing very minimal. I was on the air with the 5000D once, and the station broke in and said, "I want to comment on your signal." And I thought, uh-oh. He said, "I have a K3 and a P3, the pan adapter." And he said, "You have the cleanest signal I've ever seen on the air." That was the 5000D driving an Alpha 89 pair of 3CX 800s. So the class A, as long as you didn't run any ALC, was at least 10 dB, if not 15 dB better than the average rig today. 75 watts, though, is usually enough to drive most amplifiers, except for like a pair of 3500Zs. It won't drive that, but a lot of amps, that was adequate. And certainly the 8877 was.
Yeah, that's the maximum power. It goes 75. And okay, thanks. I always have it in class A when I'm on.
Good for you. Well, you're going to have a good signal. What are you running for an amp then?
Alpha 99.
All right, you're great. I'll talk about amps here in a bit because unfortunately, quote, linear amplifiers are not as linear as we'd like. Any other questions at this time?
The ICOM 7851 is looks like its signal is pretty clean. How are they doing that?
You know, I've got some transmit data on that. And matter of fact, I just got shipped another one on loan from DX Engineering because he wanted some additional information. I'm beginning to have a database of amplifiers and rigs as far as the sideband performance. The rigs that run on 50 volts, which would be the 7851 and the TS990S and the Apache 8000, they're about 5 or 6 dB cleaner than the typical 13 volt rig. So that is an advantage. It's easier to have a cleaner PA in the rig if you've got a 50 volt PA, and that would probably include the MP. I haven't seen an MP, but one would expect that.
Thank you.
How about the Expert Electronics Sun SDR2 Pro?
I haven't tested that, but Adam, VA70J has, and he had enough issues on the testing that I don't know that he's done any further testing with it. I did have an MB1 a very long time ago when it first came out, and it unfortunately didn't continue to operate in time to actually use it on the air and run it through the lab. So I don't have very good data on that.
Thank you.
I have a comment.
Yes.
Kind of a different subject. As a CW operator who likes having QSK or even the quasi QSK, one thing I've noticed on a lot of on some radios is that the total group delay time through the receiver has been increasing over time, so that there can be many milliseconds, if you will, of time delay between when the RF hits the antenna and audio begins to come out of the receiver. Is this something that might be measured in the future?
Oh, I do measure that. I've probably got at least 10, or if not more, radios that I have a delay, and it's amazingly different. For instance, well, like the 781 was like 2 milliseconds, and most of the current ICOMs are like between, whether it's sideband or CW, a little bit worse on CW, but like 10 milliseconds. The original Flex 6700, before they gave you options to degrade the shape factor of the DSP filters, was 170 milliseconds.
Right.
And then if you added the M, like the 6600M or a Maestro outboard, it was even longer than that. Now they didn't give you the option now to trade off shape factor for delay, and you can get it down to about 50, but the default is 100, and 100 milliseconds in QSK is kind of a long time. And I'm just measuring the receive delay. There's obviously some transmit delay there. So I've got a bunch of data. If anybody wants delay data, latency data, just shoot me an email and I'll send you my PDF.
Appreciate
Rob?
it. Thanks.
Yeah, hey, Rob, W1RH here. Just a question about the FT1000 MPs. I used to run a couple of those SO2R. My run radio I had modified for key clicks. My Molt radio I never did modify. Would you consider that one of the widest radios on the band?
Yeah, it was. W8J, I complained about that forever. And I think he fixed it for like $2 worth of parts. So I'm going to be talking about key clicks here in the last third of it. But that's the sad thing. Yaesu has obviously been a major seller of radios for decades, but transmit noise and key clicks have been their weak point forever. And when I complained at Dayton about 5 or 6 years ago, the rep there, I said, for instance, like with the 5000D, super clean in Class A until you hit the ALC and it destroyed it. And he said it makes us louder. So, we need more focus on this on the transmit side now. I mean, the receivers now are phenomenal. You know, certainly there's variation, there's feature differences, there's ergonomic differences, but we know how to make, the OEMs know how to make radios now with clean synthesizers, but they don't have a clue on key clicks, and there's not much emphasis on distortion products on sideband.
Rob, when you're doing your analysis for the signals on the radios and the other stuff, would you kindly look at FT8, FT4 signals too? I got a unique problem where my solid state linear nominal 1 kW, I not put more than 500 watts out without getting an extremely trashy signal.
That's interesting, because an FT8 or FT4 doesn't have two signals at once. So what is it actually producing? If you see it on a, you know, on a separate receiver, or do you actually, what are you seeing that distortion? What's it look like?
I have not looked at it. Somebody that lives about 5 miles from me clued me in that I was had images and pretty wide signals on my base signal when I started running the higher power, so I just peeled it back. I don't know if the problem is in the at that time I was using a 7600. I haven't tried it on a 7300 yet, so I don't know if it's in the exciter or in the amplifier.
Right. Well, see, I run well, I used to run JT9, and now it's FST4 on 630 meters with the 7300 and then a transverter. And at least with the ICOM, and I haven't run it digital with this 7610, but it didn't seem to make a lot of difference, the ALC level on the 7300, as far as harmonics that can be generated on transmit. But on the TS890S, if I ran any significant ALC, I created harmonics that I could see on the spectrum scope or the waterfall. So with the newer rigs that have a built-in scope, you can see some of that. Now you can't see distortion products on sideband. I mean, you look at your display on a Kenwood or an ICOM that I have known, and it looks like my signal straight up and down, except when my friend takes a picture of me, I'm not. So that the other thing that so it'd be interesting to know if it is just the amplifier. You said, what did you say, which the amplifier was?
I didn't say it was an ICOM PW1, and I forgot to comment. It's the ALC comes up quicker earlier when we're using FT8.
Okay. Well, the PW1's not probably any better than anyone else's, and the LD MOS are certainly not. And I'll have a picture of that in a moment. So there were changes made to FT8 and FT4 by Joe Taylor to make the transition. I mean, it's switching frequencies, but it's not, they want it less abrupt, because anything that's abrupt, whether it's a rise time or it's a frequency shift like FSK or something, the abruptness affects the bandwidth. But you would think that you would hope that something that's the linear is linear enough that it's not going to mess up FT8, but I don't know. That's a good thing we'll check on that, because that's something that we can run through my lab and my friend's lab that does some of my testing on transmit, because he's got a better sampling scope. That's something we'll pay attention to, and I'll let you know.
Thank you much.
Rob,
Okay.
N6GHE, just a quick one. When you measure, do you measure receiver or transmit LO phase noise? Do you measure that directly, or do you see the inference of the performance through the reciprocal mixing test?
I do it directly. I use a Perseus, which is just a receiver, and it has a very good capability and dynamic range to measure almost everything. Now you need a separate filter, crystal filter, to measure a K3S, because its noise is so low. But most rigs are limited enough on transmit noise that I can measure it directly with the Perseus, or you can measure it probably with the 6000 Flex, or probably an Apache 7000. But I just happen to use the little Perseus receiver. But and then to go above 10 meters, Rigs, of course, unfortunately get much worse on VHF, 2 meters, 70 centimeters, 23 centimeters. So I down convert those 3 bands with a very clean synthesizer and a plus 17 dBm mixer down to 20 meters. And so I measured the ICOM 9700, for instance, for a transmit composite noise, and compared my data to a $150,000 Roden Schwartz out of Europe at PA5Y, and our numbers were within a fraction of a dB. So the numbers I can on rigs that I've tested are pretty good.
Thank you, Rob.
Okay, let's wrap it up here on the transmit stuff. This is the cleanest transmitter I've ever owned. This is a 2-tone test, like you see in QST. And there's 2 things that are important here. Number 1, the distortion products measured the way you should measure them, where you put your 2 cursors on the one cursor on one of the 2 signals. You know, there are 2 signals in the 2-tone test are equal, and you put the other cursor on whichever product you're trying to measure, 3rd, 5th, 7th, 9th. So there's the 3rd order product. It shows up in the right-hand corner, minus 36.5 dB. That's great. But advertisers like bigger numbers, so they just add 6 dB to it. It doesn't change the distortion product, but the number's bigger. So this is just the way it is. It's kind of like switching your car from miles per hour to kilometers. The number gets bigger, but you're still going 60 miles an hour. So the other thing to look at here on this Collins is 80 dB down, we're gone at plus or minus 10 kilohertz. This is astoundingly clean. And this is actually that Mark V is even better than this by a few dB, by about 5 dB. So the Mark V in Class A is better than this. The 3rd order was down 42 and the 5th order was minus 70. So we could be transmitting like that, but very hard to do these days. So this is the cleanest transmitter I've owned. I don't own it anymore, and it's kind of out of production. So here's a 50 volt PA that I mentioned earlier. Now this is the 990. I don't have that anymore. It took an EMP hit, saw better days, but that was only 2.5 dB worse on 3rd order. But look how much further out it goes by the time you get down 80 dB. Instead of being plus or minus 10, it's plus or minus 18. But that's still better than your average 13.8 volt rig by about 5 or 6 dB on just 3rd order. So here's a K3. It's about 10 dB worse than the Collins was. But the main point of this slide is to show why on sideband we were able to live with those up conversion radios that had a dynamic range close in of about 70 dB. So here's this guy is now, certainly he's not transmitting 2 tones, but let's say he's calling CQDX. We're 4 kilohertz away, and his distortion products are down about 45 dB. Well, we're not transmitting tones, so let's say his average speech was only down 50 or 55 dB, or even 60 dB, which it probably isn't. But our typical radio, dynamic range of the 590 SG is over 90 at this 2 kilohertz, let alone 4 kilohertz. So you can see on sideband, we weren't really being limited by the receiver, because pretty much the splatter of a guy 3 kcs away or 4 or 5 kcs away, that was the limit. And that's how we lived with those radios that we had for 20 years, that they were just 70 dB radios. But now we got 100 dB radios all over the place. Well, here's the key click difference that's kind of shocking. We can now go into a menu on all the modern rigs, except for the Elecraft, and they don't let you screw up, and select a rise time that's ridiculous. This shows you the bandwidth of a TS890S transmitting with a 1 millisecond rise time and a 6 millisecond rise time. And you can see the key clicks at a 1 kilohertz offset are 25 dB worse at 1 millisecond compared to 6. And that's just awful. The OEM shouldn't even let you pick 1 or 2 milliseconds. Elecraft sets it at 5, and you can't change it. and I wish that everybody would just get with the program and not let this be a bad neighbor, probably by not either understanding it or just maybe what the default was. So 25 dB difference, just changing a menu setting. Here's the composite noise. We don't get a lot of press on this. Field day guys know it's a big problem. You got a neighbor a mile away, can be a big problem. So here's just 3 examples. The K3S clean synthesizer has good AM and phase noise. So it's composite noise here that I'm measuring with the Perseus. It's excellent at 10. Well, it's so good at 10, it hardly gets better at 100, but it's a big number. We look at the ICOM 7610. Well, it's not near as good at 10, but it's virtually identical at 100. So if you had field day with one on CW at the low end of the band and one on sideband, you're probably not going to bother each other. But look at the Yaesu FTDX 3000. Well, it's worse at 10, and it doesn't get any better at 100 or 200 or 300. So that's a problem. Thank goodness the 101D and MP and the 10 don't do that anymore. Let me give you just a real quick example of the real world. There's a ham in Boulder. He lives up in the foothills, so he's overlooking the city. So everything's line of sight into a ham in the city of Boulder. And he used to have a 1000 MP, and he didn't bother a ham 5 miles away, line of sight, on 15 meters, which they both like 15 meters. And the guy in the city has a stack on 15. He went to an FTDX 3000. Suddenly, S9 broadband noise being transmitted by the 3000, virtually wiping out 15 meters for the guy down in the town. So we don't need this kind of problem. And there's where the OEM just got to say, this is important stuff. Key clicks, transmit noise, splatter. I don't know if you read my article in November 2019 in QST. And I wrote this article in QST, put the headline, "It's time to clean up our transmitters." And I want to compliment the league for doing that, because I was poking the bear that we've got problems now. We've got wonderful receivers and not so wonderful transmitters. So if you don't have access to that 2019 QST article, I can send you a PDF. The same time, in that same issue, they tested the Expert 1.5 KFA amplifier. Well, the amplifier tested normally with this feel-good method PEP, not the way that, that's the added 6 dB number. So it came out 30, minus 30. It's really minus 24, but okay, we're going to go with the PEP. So they did the Apache pure signal, and it improved it 17 dB. That's a lot cleaner, and I wish that we all had a signal 17 dB cleaner. So when we talk about, quote, linear amplifiers, the league published a compendium of tube type amplifiers, which of course that's about all we had back in 1997. Every one of them in that article had distortion down in the PEP method, minus 40 to minus 50. Well, then the Yellowcraft review of the KPA 1500, minus 30, typical LD mods. The Power Genius, the one we tested, minus 30 on 20 meters. The Expert that was just mentioned in the previous slide, minus 30 unless you had pre-distortion. Well, the TS990S is minus 40. So if we've got a rig that's minus 40, let alone something in Class A that's like minus 50, we run it through a typical solid state amp today, guess what? It gets a lot worse, and that's sad. One more data point here. We're going to see much more of this, but we'll see. These input-output curves really tell the story. Now, admittedly, the KPA 1500, it's minus 30. And if you look at the IO curve, it's in blue in this case on the left. It starts to curve off, so it's probably cleaner at a kilowatt than 1500 watts. But at least the curve is more or less straight. But then if we look in July last year of the ACOM 1200S, well, in this case, 20 meters is red. Well, it's pretty straight up through about 700 watts, and then it goes to hell. And that's just awful. So I wouldn't run that amplifier at full power. And here was the data they published, and they actually showed the thing. Here's the key. If the third order looks like it's better than the fifth order, that number is meaningless. So at a kilowatt, The fifth order was minus 33, which is not very good. Comparison to these other rigs, the SPE, the KPA, or the Power Genius, they're 38 to minus 40. But if you ran this ACOM 1200S at half power, well, then it was good. So we really need to know what our amplifier is capable of, and hopefully we care whether we've got a splattery signal or not. So bottom line.
Rob, if I can interrupt a minute.
Sure.
The Power Genius power supply by Flex is it, I did some research. The transmit receive time is 40 milliseconds. They use an open frame relay. That is absolutely unusable in CW.
Really? So they don't have a vacuum relay or pin diodes or anything?
Nope, they use, they brag about a good quality German they don't say open frame, but that amount of switching time, or they're doing something to cover some other problems. But that amplifier is designed by 403A, and it has excellent quality. I thought it did have, they claim good linearity, but I took that off my prospective amplifier list because they'll never run QSK.
That's interesting. Well, I'll have to do some research on that. Well, the Power Genius, it was interesting. It was better than sort of typical on 40, but very typical on 20, and actually worse if we go back to here. The Power Genius was minus 30 on 20, but 27 on 6 and 10, and that's the PEP number. So take 6 dB off that for the real number. So maybe they're trying to, like you said, maybe covering up for some other issue. I don't know. We can find out on that. That's fascinating information. So we've got 6 major OEMs making competitive products. I think you may find today that broadband noise, I'm going to use noise in the generic, splatter noise, key click noise, broadband composite noise, transmit noise are can be the limits. We've got these wonderful receivers, and the transmitters are can do a lot better. So there you have it. Do we have any other questions or comments? And before we call it a day.
Hey Rob, this is Jay. You said you wanted to know if anyone was using the 705. What did you want to know about that?
Well, it's sort of the newest potential SOTA parks on the air radio. It's DC to light. It's a little more it's heavier. I mean, the KX3 is like a little over a pound. The KX2 is a little under a pound. This is 2.5 pounds. But then it's got all sorts of features. So I'm just wondering, what are the guys that are climbing up the hills doing these days? Is it being a popular radio?
Well, I have one that I've had for a couple months now. I also have the 817, and I haven't compared the two side by side up on a hilltop yet, but the features on the 705 that I like are the QSO recording, the ergonomics with that, which 817 doesn't have, or many other radios have. So I don't have to log anything. I can just record everything and go back and write it down later. And the other feature is the built-in macros for keying for CW and for voice. You can just keep hitting a button. You don't have to keep talking all the time and wait till someone answers you. So those are probably the two best things for SOTA that I like.
Okay. Now, what about is the band scope useful, or since you're calling CQ, is it less useful than it might be if you were tuning around the band?
It's useful to find a space to call CQ in quickly. So that's what I use it for. And to see if there's anyone up or down the band. If no one's answering on my frequency, I can go somewhere and find some traffic. And it's pretty good in bright sunlight. I've been up on a hill with snow and in the sunlight, and it works pretty good.
Well, that's amazing. In the snow, I need sunglasses on.
Rob, Bill, N6GHZ. I didn't check your list lately on receiver or transceiver performance, but have you tested the FT817 now that Jay brought up that particular transceiver?
I've not tested the 17 or the 818, either one.
Okay,
I have 9 QRP rigs up there now, and there'll be 10 when I put the Zygu up there. But I don't have access to everything. Most of my radios come in by people who are just nice enough to loan me one.
okay, thanks.
Rob, one probably rather silly question. By the way, if a signal report for the clean signal was 5 or 6 years ago, it could have been me, because I have done that a couple of times on the air. The question is, if you have a less than clean transmitter and you put it through a less than linear amplifier, as you've demonstrated, the noise and the crud that you transmit is collectively worse or significantly worse, or how does that play out?
I would assume in general, somewhat worse. I mean, things could add up in phase and out of phase. Who the heck knows? But I would say somewhat additive would be a best guess.
Okay, thank you.
Rob, there's several other solid state amps out there. The what was ICOM's
Well,
real early amp?
Oh, KL 4KL.
Yeah.
I had one of those. It was terrible. I had a Kenwood 922 pair of 3500Zs, and at a 5 kc offset, the 4KL was at least a 6 dB worse, and so I got rid of it.
Any other solid state amps pop in your mind you want to talk about?
You know, there isn't one. I mean, unless you're doing pre-distortion and you have a sampler, although, you know, the newest amps have sampler outputs already. So they're waiting for pre-distortion to come down the pike. And, you know, the KPA 1500 has it, the Hilberling out of Germany, the SPE believe have it. So you don't even have to add a sampler. But anyway, I don't think there's a single LD MOS amp that can touch a really clean tube amp. Until we get pre-distortion is more common, we're stuck with an unfortunate situation there.
In the bad old days, I can remember a class we were using in tubes, and it's the length of the transfer curve, voltage span. So tubes with their longer voltage, you can actually find an easier, more linear spot on their transfer slope to do that. And the 3CX 1500 8877, great example of, you know, a long, almost fully linear portion of the transfer curve.
Yeah, exactly. And that Collins, it was so clean, not as clean as Class A, but it had negative feedback. What I don't understand, because I'm no amplifier designer, is the LD MOS have lots of gain, and some of the amps have a pad in the front to well, for two reasons. One, because of the stupid 15 dB gain rule, the FCC, but you don't really want an amp that you can drive with 5 watts with a 100-watt rig. But I don't understand why some sort of negative feedback in an LD MOS amp can't clean things up, but it doesn't appear to.
Rob, I have a question, Barry, K6ST. I have a ICOM 7300. It's an SDR. It's a great radio. Every now and then, if there's a signal nearby, you get there's a little light comes on. It says OVR, which means it's overloading.
Right.
And is that what's going on? And is that germane to SDRs versus superhits?
Yes, and the for instance, the Perseus and the Apache and the ICOM all have an overload indicator, and that's nice. The Flex do not. I don't know why. It's in the chip, but they don't use the annunciator. In my case, the only time the OVF has flashed was about 3 or 4 years ago on 10-meter ARRL contest, and the sunspots were terrible, and I had preamp 2 on, and for 20 seconds it was blinking away. Now, I didn't hear much. Well, you know what I think it was? My 5-element Yagi at 65 feet is 1,000 feet from the road. I think a trucker drove by on 11 meters running maybe more than 5 watts, and it overloaded the radio. So that's the case where the ADC, the direct sampling radios, they're looking at likely a half octave. Now, in the case of the 6600 from Flex, they do have just the ham bandpass filter as an option. So that isn't going to at least be seeing 11 meters, but in addition to 10. But you've got that difference of potential overload. All the direct sampling will be somewhere in the range of mid 120s, where a K3S is like 150, and a 101D is about 150. So that is where the fact that the radio doesn't have to see signals out of passband.
Do you know yet what the K4 looks like?
Well, Wayne has said, and maybe Eric too, in these presentations recently, that they expect the blocking to be in the 120s. Let's just say mid 120. I mean, if you look at my website, you can see that kind of data. And dynamic range probably in the mid to upper 90s, because that's where we are with technology today. And then the HD model, I was a little surprised. I heard Wayne say maybe a few months ago that it might be 10 or 15 dB better, but the K3S is about 150. So I would kind of expect the HD to be close to 150 on blocking. So we'll just have to see. But I mean, there's no magic. And most of the time, I mean, if we're talking about without a preamp on and no attenuator on, most of the direct sampling radios overload about S9 plus 65 dB, something like that. That's pretty strong, but that's not unheard of locally, certainly in local. I mean, that's a hell of a skip signal, but local is a different story. 160 meters, you can have a guy 10 miles away. It could easily be 70 or 80 over 9. At least on one.
I don't have a very big antenna, and it's rare that it comes on at my QTH or around. Now, I took it to field day one time. All bets are off, because you got RF everywhere.
Right. And on, so unfortunately, the 7300 only has one attenuator. So you're just going to have to use the RF gain. The 7610, you can adjust the attenuator in 3 dB steps. That's really cool. And I talked to Tim Duffy about running the 7610 at WRTH in Germany. Was that a year and a half ago or 2 years ago, whatever it was? He said, we were running 9 dB attenuation on 40 meters at night. Well, that's no big surprise and no problem at all. I mean, remember I said 40 meters probably has at least 20 dB more noise than 10 meters. So you can run a 9 dB attenuation or 12 dB attenuation, and you're not losing anything except keeping that ADC from seeing those signals.
Thank you.
This is Rob, K6KM. I have a question. I'm fairly new on ham radio. I've been playing for about 3 years, and I have a lot of RFI and floor noise here, pretty high from urban side. And I play with the noise reduction button. I have a 7300. It doesn't seem to help a whole lot. Maybe the setting 2 or 3 out of 15 helps a little bit, but that's about it. Are those noise reduction algorithms useful, maybe in other radios, or is this one only, or is it a general thing?
Well, in general, you're right. I mean, I run on CW the noise reduction on a 7300 or a 7610 on maybe 3, maybe 4 at the most. And on sideband, 1 or 2. And then it starts sounding funny to me, but that's just me. I mean, some people like it up at 10, but that's, their call. The only company that I know of that has done dramatic noise reduction, it can be blanking and noise reduction like you're talking about with the 7300, is the Apache. And all that software is written by Warren Pratt, NR0V, who now lives in Loveland, Colorado. So he's 50 miles from me. Used to live in California. And if you go up to my website, and by the way, my website's being moved to a new server, so if it's down for a day or something or other, we'll deal with it. But anyway, if you go to nc0b.com/nr0v, nc0b.com/nr0v, as in Victor, there's 2 audio clips up there that Warren presented at Dayton at a Tapper presentation 3 or 4 years ago. You cannot believe the noise mitigation that he produced with his algorithms. So there, if you've got the programming smarts and the horsepower of a computer, in this case, it's a Windows computer that can do this kind of number crunching, it's possible that to be in a better shape than most of us are. Now, in my case, I'm out there in the middle of nowhere and I don't need much of it. I just like kind of taking the edge off of noise. But you're right. If I'm here in Denver, ugh, I'm probably the same boat you're in. And I've got a 7300 here in Denver.
Hey, Rob, question for you. I run a FTDX 5000, but for a backup rig, I have a choice of either the 3000 or an older FT 2000 that's loaded with the AC0C roofing filters. I'm rig poor on backups, and I need to get rid of one of them. Which one is a better choice there?
You said the 3000 and the which one of the two again?
The 2000 that has all the AC0C roofing filters in it.
So the 2000 and what was the?
Oh, I run a 5000, but
right.
I have a 3000 as a backup choice, or a 2000 with the roofing filters in it, and
okay.
I need to sell one and keep one.
Well, from a transmit noise standpoint, key clicks and composite noise, the 3000 should go away.
Okay.
And I'll probably get shot for that, but that's where it is. The 1200 had key clicks, but that can be fixed. And the composite noise isn't great. So I don't know. I'd say get rid of them both and buy an old used K3. But you know, there are going to be a bunch of them around once they start shipping K4s.
Well, ergonomically, I've tried to play with the K3s. I'm not a real fan of them. They too many menus and buttons for my fat fingers. So
well, their K3 has some limitations there, no question about it. It has some interconnect problems sometimes. After you got to take it all apart and put it back together. So there's no perfect radio out there. But the 3000 is unfortunately on the, if you've got neighbors, they would be happy you don't put the 3000 on the air.
No, I'm like you. I live very rural. There's
So
nobody close. But
yeah, that's good. My closest ham is 13 miles away. So on 10 and 15 meters, pointing our beams at each other at legal limit, we're only 30/9. So we're lucky.
Thank you, Rob.
Here's it real quick. Here's an example of this problem of transmit cleanliness. AI0L used to have an ICOM 7600, and that did not have good transmit splatter. It was 10 dB worse than a Pro 3. And so he was running that and PW1, and he was getting complaints. So we spent a couple weekends pointing our yikes at each other and making measurements on our signal, his signal quality. So what I did was listen on the opposite sideband on 10 and 15 and see how far down the opposite sideband was. So he was 30/9. And well, actually we kept it constant. So with the amp off, he was 20/9, and with the amp on, I put the pad 10 dB pad in. So the desired signal was always 20/9. When he went to the opposite sideband with the 7600 and the PW1, his splatter on the opposite sideband was S8. He then went to an old ICOM 735 that's 30 plus years old, and an alpha that had been modified for a pair of 3CX800s. His distortion on the opposite sideband went from S8 to S3. So he sold the 7600, he sold the PW1, he bought a TS990S, and he's using his alpha now. So that was a big difference.
You know, Rob, speaking of the wrong sideband, one time I was in a contest and somebody had a problem on their amp and I didn't know this. And so they were calling on the wrong sideband. It sounded like calling, and I calling them, and nobody's come back. I don't know what's going on. Later, I checked. They said they had a problem on the amp, blah, blah, blah. So that was a real life example of what you've seen in the labs.
Yeah. Well, let's see, I guess it would have been one of the recent contests end of last year. I don't remember now whether it was CQ Worldwide or AWL 10 meters, whatever it was. And I was paying attention to maybe it was even the 10 meter on CW. I don't know. There were stations that were key clicks were 35 kilohertz wide, and one station had transmit composite noise 50 kilohertz wide. I could copy him calling CQ on his transmit noise 25 kilohertz off frequency. And I tuned him in and I got his call. And he had, besides his main signal, he had 9 other signals that were spaced something like 100 hertz apart. And so I just was flabbergasted at these horrendous signals that were on the air. But when you're on 10 or 15 meters, the signal to noise can be so much better. You can see these awful signals that you wouldn't really know it on 80 meters because the band noise is so higher.
Also pretty awful with RTTY.
Okay, that's interesting.
Bob, what do you notice on RTTY since it's decoding on the screen?
I'm looking with a flex, but what can really be annoying are what are the equivalent of key clicks actually. The flex has got some pretty nice filtering in it, but you can't filter out stuff that is right there in your passband.
What happens practically in the RTTY? Is it messing up the decoding or what's going on?
It's going to mess up the decoding. Go ahead, Ira.
That happens with FSK radios that don't have any filtering post the switching, post the modulation, like the Yaesu radios again.
Well, here's a case where with either a superhet with a direct sampling band scope or just a direct sampling radio, what you see on your screen is reality. I think in the past, like 30 years ago, if I heard a guy splattering and I got on his frequency and broke into the QSO, said, you're wide, what would the guy say? I'm overloading, he's overloading my receiver, go away. Well, you can't get away with that excuse anymore. If you see a guy that's 30 kilohertz wide, guess what? He is.
Rob, what effect would pure signal have on AFSK?
It would clean up anything if it's a distortion product that's being created in the Riggs amplifier or the external amplifier. Now, if there's a problem in what's actually produced at the DSP level, well, you can't fix that, but I would hope that wouldn't be a problem. But I'm not a RTTY guy, so I don't know that.
So it's not just for complex audio, it's for any audio or perhaps even CW?
I don't think it would have any effect on CW. I mean, if the King sidebands are there, you've got, let's say you had a 1 millisecond rise time and you've got, it's bandwidth all has to do with how abruptly does something change. You put a rock in the key, you're not very wide, exclusive of composite noise or something. But once you start keying it, the shape of the keying of the rise time and the fall time and the speed of that drastically affects the bandwidth. So if you've got like that 890S at 1 millisecond and you're 25 dB worse than at 6, that ain't going to change.
Okay, thank you.
Barry, one other question. Have you looked at any SDR receivers, not transceivers, but receivers? Because there's a whole lot of them on the market.
The only one I have owned and tested is the ICOM R8600, which is a DC light radio, and the Perseus, which came out, 15 years ago or whatever. So those are the only receivers. Well, let's see if I test anything else.
The AirSpire or anything like that?
No, I haven't done the AirSpire. The little, we'll just call them dongles. I haven't done any of those.
Yeah, thank you.
All right, gents, any more for our guests before we have one more actionable item of business here? If we have no more questions for Rob.
Thank you, Rob.
All right, very good.
Thank you, Rob.
Yeah, absolutely, Rob. Thank you very, very much. Thank you for your time and all your expertise. Greatly appreciated.
Okay, my pleasure, and enjoy WPX.
Hey, Rob, before you go, I did record this. We're not going to put it up on the website without your okay, however.
Oh, of course. And anything I do is open to the public domain. So
Thanks, Rob.
then people can shoot arrows at me. So
Okay.
See you in the
all right.
contest.
Stay well, Rob. Stay
All right.
well.
Bye-bye.
Well done. Thanks.